Smart notebook just crashed.
Blame it on the tabs. All right, while this is opening up a beautiful, blank, fresh, clean Smart Notebook document, ready for your questions. Okay, that's today. In case you missed yesterday, today is rapid fire. Less emphasis on the rapid, but fire away. Questions that you'd like to review. All right. But before we do that, this is our last full day together. So, in case you missed yesterday, I don't want to say assigned. Assigned is the correct word, but it's not required. I have assigned optional AP Classroom work. All right. The last couple of unit progress checks, a full released exam in case you feel like you need more work to get ready for the AP test. However, with this week, your emphasis, your focus should be on the AP test you have this week, right? For the most part. You should also be reviewing, but make sure I don't want to overload you or overwhelm you with a lot of work at home. You should be focusing on those tests as well. All right? Now, having said that, we only have a few days left. It's crazy. So one thing you should be doing, I did try to catch up on grading this morning as far as your weekly work that you turned in last week or anything that was supposed to be makeup work. And so you should be starting to work on, this should not take long. If you choose to not take the final exam, you can take the year-long average as your final exam grade. So we talked about that a little bit yesterday. The way you calculate that, or maybe it was 7th grade. I forget what class I talked about it. Anyway, the way you calculate that is every marking period gets. Oh, this is not a good start. Oh, this is not good. It's the tabs. All right, double marking period 1, double marking period 2. Don't double the first semester exam. I'm writing it for those who are watching the recording. Do you think it's maybe because of the recording? Yeah. It doesn't happen until I record. All right. Now, normally to calculate your year-long average, you would add the second semester exam and divide by 10. Right? So we're taking away one part. So you add up these and divide by 9. And that is your year-long average. That would then get put in as your final exam score. So here's what's going to happen. To streamline this process, you are going to calculate this once grades are done. Okay? So next week, sometime, I won't be here Tuesday. I'll be at the sectional tennis tournament helping out. But at some point, this is going to get calculated. And then you're going to bring it up to me. We're going to verify. I will go through and verify. But it does help to make sure. This just confirms that we're on the same page, all right, for your second semester exam. There's a very small window of time where, especially for like the top 5, top 10, whatever they want for grades to be finalized for class rank, there's a very small window for seniors for me to get grades finalized. Second semester exam, grades to get put in, and the grades confirmed with administration for those. So if you guys could just do that for me, we'll confirm, we'll make sure we're on the same page, and then we'll be good to go. So next week, you're going to be doing that very early in the week. You're going to turn in your calculators, make sure the calculator covers get turned in with the calculator, and then the cord as well if you borrowed one, and then the book. All right? So we can talk about what that looks like here in the next few days, but I always debate when to do the book. I don't know if you guys are going to be using the book for a review or not. I don't know. So I sometimes hold off, but I don't know how many people are actually using it for a review. All right. Where do you want to start? Who's got a topic? Oh, jeez. Cool.
Related rates.
Related rates.
Triangle and quoting out the purpose.
All right, so we are eliminating possible culprits on why it's lagging. Mirror might be the number one culprit, but we'll see. All right, related rates. I apologize to you over there. Yeah, what types of problems did we go through? I heard a couple. Balloon always looks. Is that right? It always looks wrong. Right?
No, it's
I think it's too
long.
long.
It's
It just always looks wrong.
yeah.
Balloon problems.
Is shadow related rates?
Yep. Ladder.
Shadow.
Oh, the cones.
Yeah. The Jane problem. Don't get me started. Love that problem.
Cylinder? I think a cylinder in here.
You're gonna wait to date a girl named Jane. You're the one I've been waiting for. Why? Your name's Jane. All right. Shady problems. So yeah, this is one where we got like typically a lamppost, a person. Now, here's the deal. You have to be careful. There's a couple things that they may ask you that trip students up. One of them, how fast is the distance between the lamppost and the person changing? All right. That's this length. How fast is the edge of the shadow changing? Okay. That would be this entire length, right? I mean, this is the shadow, but the edge of the shadow is here. You may need to use the whole length and see how fast that length is changing. All right. How fast is the angle? Not in the shadow problem. I haven't ever seen them ask how fast is this angle changing. Because how would you describe that? I mean, the path of the light and the ground, like it'd be hard to explain. But if there's like a rope, like you're reeling in a boat and there's a rope attached to a pulley, you may be asked how fast is the angle changing, or even better, the ladder, right? How fast is the angle changing where the base of the ladder touches the ground as the ladder slides out? So these ones, again, we're not. If you want to do a specific problem, you can find one and let me know. We're just kind of doing an overview right now, okay? If you want to do specifics, find a problem and let me know. This would come to a grinding halt if I took the time to search a problem and find it. So I'm fine if you Google it, let us know. Otherwise, things to watch out for. 1, Pythagorean theorem. 2, SOHCAHTOA. 3, similar triangles / ratios. What I mean by that is setting up a proportion. Like they may call this X, they may call this K, I don't know. And you may need to do K over X plus K. Right? I mean, do you see how K is the side length of that small triangle? And if you have to set it up as a proportion, you may need to do over x plus k, the whole big triangle, and then the person's height, right? Person's height over the height of the lamppost, which is not going to change, but we'll call it, I don't know, m. And you may have to do some sort of cross multiplying, dividing. If you're going to have to take a derivative of that, which you're going to have to take a derivative at some point, you don't want to take it in that form. You probably want to cross multiply first, get it into a nice form, and then take the derivative. And remember, related rates, the derivative is always with respect to time. All right, always with respect to time. So every problem is a chain rule. The derivative of x is not just one; it's dx dt. All right. I'm not sure if that was enough of a review or not. Cool.
Not a problem.
Sure.
Do that. Ready?
Hold on one second. These are the problems that as we read it, we categorize the information as things that's given, things that are changing, things that are constant, and then what are we trying to find? Okay? Because when I take the derivative of this lamppost height, it's going to be 0 because it's not changing. Ladder, not changing. The derivative of that would be 0. So as we go through, I apologize, Mira. You're not the culprit. This is like a good episode of Clue, or a good game of Clue. Episode? Wasn't it a show too? Okay. Throwing some.
Shadow.
Yeah, close enough. All right, go ahead, Cole.
Man 6 feet tall walks at a rate of 5 feet per second.
Oh. All right. What is 5 feet per second? Based on my picture. dx dt. Do you agree? It's the rate at which he is moving. It's how fast x is changing. Everybody with me? dx dt is 5. Go ahead.
Toward the street light.
Never mind. What do we call that? Negative 5.
That is 16 feet above the ground. At what rate does his shadow change when he is 10 feet from the face of the light?
So x equals 10. This is a reminder that, yes, x is changing, but we're taking a picture of this situation when he is 10 feet away, right? So x is 10 in that situation. dx dt is negative 5. M, 16. What else? We're trying to find? Hello.
Hi. We have a question for you.
Calculus?
Yeah.
I'm teaching. What's going on?
Well, I can bring it later if that's better.
Is it like, show me how to do this kind of thing?
Yeah.
Okay, yeah, we'll do it later.
Okay.
Yep. What else? Find dk dt? Is that the way you're reading it, Cole? Did you say how fast is the length of the shadow changing?
Length of his shadow changing when he's 10 feet.
Be careful because, the length of the shadow here is k. If it said the tip of the shadow, I would want to be more careful with whether it's x plus k or k. All right? Now, I set this ratio up without reading this problem, before we move into this problem. So I'm not promising this is going to be the correct setup. All right? However, do we need to consider that the height of the person and the height of the lamppost are changing? No, they're staying. They're 16. All right. Tell you what. Go ahead and take a minute. Try to set this up. you get -3? I could have done it wrong. Did anyone get -3? Does anyone strongly disagree with me? It's not -3. Is anyone strongly confused? Okay. All right. Did you get the 6/16 equals k over x plus k? Dom, would you close that? You're gonna miss that, Dom, aren't you?
Yeah.
You're gonna miss closing the door. Dom, the doorman. All right. Ready? Do you see the similar triangles? Angle, angle similarity. Yes, they share this angle. They both are right triangles. So 6, the height in the small triangle over the height in the big triangle, 6/16. Why can I put numbers in there again? So constants, they're not changing values. Right? They are always 6. They are always 16 in this problem. I would be very careful putting in constants. Make sure they're only for parts of the problem that aren't changing at all. Equals, now listen, if I do small triangle height over big triangle height, then I need to do small triangle side, okay, over big triangle side, which is x plus k. Are you with me? I set up this proportion. I cross multiply. Why do I want to solve for k? Well, I want to find dk dt. If I want to find dy dx, I would solve for y. If I could. If I want to find dk dt, I want to solve for k. dk dt equals 3/5 dx dt. Are you guys okay with the derivative with respect to time? Yes, yes, yes. I plugged in dx dt, which is -5, and I got -3. Questions on that? A little shady. Others? Other questions in general about related rates? I have seen that on an AP test. I've seen a shadow problem. Tom?
Would the shadow problem be a multiple choice or an FRQ?
I don't make any promises. I haven't seen it on an FRQ. I've seen it on multiple choice a couple times. Next topic to review. That's it.
New substitution.
U substitution. All right. Do you remember the process for U substitution in general? We try. What do we try first? Anyone? Well, first of all, you look at the integrand and you say, I don't know the antiderivative of that. Okay. Next step, you try to simplify the integrand algebraically. We don't want to go right to use substitution, okay? So quick refresher, a quick Google search. You're looking for something that's in the form of f of g of x times g prime of x. Here's what I told you when we went over it, and you weren't ready. When we talked about it in the first time around, you were not ready for this explanation of it, okay? You should be ready at this point. If you see a function that looks like this, what does this mean? A g of x function wrapped up inside of another, and then the derivative of that inside function elsewhere in the integrand. Remember that? That's what you're looking for, okay? So like, if I see a secant squared of 5x plus 1 times 5, I look at that and I say, oh, it looks like a 5x plus 1 is inside of secant squared. And the derivative of 5x plus 1 is 5. It's outside. So I would let u equal the inside. Du would be 5. It's already there. I don't need to adjust anything. and I go from there. All right. Next one. Let's look for a good one. Ooh, wow. Beautiful. Madison, I have not looked at this worksheet. I just Googled it. You get the benefit of picking any problem that we're going to do. Which problem do you want to do? Oh, challenge problems. And just in all honesty, the ones they put on here, oh, come on. The ones they put on here are not typically too rough on the multiple choice. These are probably not going to be on free response. I've seen a part of one in there, but like not solve this use substitution problem per se. 13. Where are you, 13? There you are. She's not holding back. Now, what's the rule? What was the rule for picking u? You're going to let u equal some part of the integrand that like if it was f of g of x times g prime of x, we're looking to let u equal the g of x part because the du, the g prime, was elsewhere in the problem. Remember that? So do you see one of these two portions whose derivative is elsewhere in the problem? The derivative of sine inverse is elsewhere in the problem. Do you remember sine inverse of x? 1 over the square root of 1 minus u squared, right? Remember that? So if we let's try it. If we let u equal sine inverse of x, du is 1 over the square root of 1 minus x squared dx. So my sine inverse is going to be my u, and my 1 over the square root of 1 minus x squared dx is my du. There's no adjustment for a constant necessary. So what does my integrand look like now? Well, the blue gets replaced with the red gets replaced with a. That's an easy antiderivative, isn't it? What is it? 1/2 u squared plus c. Thank you. Plug u back in. 1/2 sine inverse of x quantity squared plus a constant. And the final check, I would quickly take the derivative of that in my head and make sure that you get back to where you started, because that's the fundamental theorem of calculus. This would be a power chain rule, right? Power chain rule. 2 comes down, 2 times a half is 1. Leave the inside alone. Sine inverse x. So the first times the derivative of the inside. 1 over the square root of 1 minus x squared. Do you see how it goes back to the original? You good? One thing I want to warn you about, okay? And I can't remember the exact problem. Maybe one of you have your packets. I forget if it was in the packet I gave you or not. It was something like this. And it was like multiple choice. Remember that? I don't know. Do you guys remember something like that? I'm trying to remember the problem. What they're trying to get you to see is that you're going to let u equal what? 2x. du is 2 dx, right? And so 1/2 du equals dx. And so the u substitution on this would be the integral of f of u, and then dx gets replaced with 1/2 du. It's a u substitution without needing to know an antiderivative. They like to test you on that sometimes. All right. So if you see a composite function generically in an integrand like that, they may be leading you to a u substitution process. Was that enough for you, Madison? And again, if you guys want to go to, to practice more of those, this quiz was kind of rough, to be honest. It might be a good idea to practice some of these. 28 is a pretty good one. Can you see it? Sine of ln x over x. Sine of ln x over x. What would you let u equal? Ln x should be sine of u. And then du would be 1 over x dx. Okay, no adjustment necessary, right? It's just going to be integral sine of u du. What's the antiderivative of sine of u? Careful. Negative cosine of u plus c. Plug u back in. Negative cosine of ln x plus c would be the answer. Okay? Next topic. That one?
I don't know if you said say something.
Avery.
We do trapezoidal sum.
Trapezoidal sum.
Love those.
Table. Function.
Table.
Table. I see them in tables a lot. Yeah. No need to get angry. All right, let's pretend this is in some sort of FRQ problem, whatever. They might give some sort of information setting the problem up where they say x is in time in seconds and r of x is in feet per second. All right, use a trapezoidal sum to approximate, and here's where they can kind of diverge a little bit. All right, what if they say use the trapezoidal sum to approximate the displacement of the particle from 1 to 17? So wouldn't an integral usually do that for us, right? An integral from 1 to 17 would give us displacement. But they're saying, well, I don't know what the function is. I don't know the antiderivative. Let's just use the trapezoidal sum to replace that. And they'll have to say use the trapezoidal sum with n equals 4. Okay, what if they don't say displacement? What if they say use a trapezoidal sum to approximate the total distance traveled of this particle? Okay. Then you're going to need to find each trapezoid, each 4. And whichever ones have negative area, make them positive before you add them up. All right. So we can still do total distance traveled without integrals. We can use Riemann sums. We can do trapezoidal sums with this process, and just as you are calculating each of the areas, make them positive. All right. So the third prong in this fork of trapezoidal sums. Is it the trapezoidal rule where I use that fancy formula, or is it trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4, do them all separately and then add them up, right? Because the trapezoidal rule is when all of the blank are the same. Careful. The heights, right? Aren't the trapezoids drawn? I know what you mean. Aren't they drawn like this? And remember the bases are the parallel sides. Aren't the H's the width of each interval? So we need to be careful. If all of the H's are the same, you can use the trapezoidal formula. Here's a quick piece of advice. It is very rare that you need the trapezoidal sum formula for the AP test. They, most of the time, now that I say that, they'll probably, throw it on there. But most of the time, you could do it with 4 separate trapezoids. Okay? Well, I would organize my work this way. If we're approximating displacement, approximate displacement on the interval from 1 to 17. All right. Trapezoid 1. Well, what's the trapezoid area formula? Do you remember? Yeah, I remember it as half the bases times the height. I like to remember it like a triangle that's been cut off. A triangle is half the base times the height. A trapezoid is half of the bases added together times the height, since there's 2 of them. So for the first trapezoid, be careful. A lot of people messed this up when they were doing it in this section. How do you find the height of the first trapezoid? Subtract the x's, right? Remember, this is the height. It's from the first x to the second x. Well, 3 minus 1 is 2, so we have half. That half has nothing to do with the height. B1 plus B2 times the height is 2 for the first trapezoid. The heights are, nope, I messed up too. The bases are -4 and 6. And I just made these numbers up. I don't know that they're going to come out nicely. The first one's nice because the 2 and the 1/2 cancel. We just have -4 plus 6, which is 2. Trapezoid 2, 1/2. B1 plus B2. Well, for the second trapezoid, the first one went from 1 to 3. The second one is going from 3 to 7. What are the bases for the second trapezoid? 6 and 18. And the height of the second trapezoid is 4. Well, half of 4 is 2 times 24. Would you get 48 for that one? 48. And then you do, Avery, you go from there. You do 3 and number 4. Okay. Now, one other thing I have seen them do is to give you more information than you need in the table. Maybe they'll give 8 intervals, but only ask you for 4 trapezoids. You just need to skip a term, skip a point, right? An x and a y, right? Does it make sense? So you'd go from 1, unfortunate. In that case, you would go from 1 to 7, all right, if there were 8 terms. And you do, the height of that trapezoid would be from 1 to 7, 6, and then -4 and 18 would be your bases. Are we good? That pops up a lot we talked about that when we did our topics of FRQs, especially when the tables pop up, trapezoidal sum or Riemann sum. Please be careful if you're doing a Riemann sum and LRAM, you use the first data point, you ignore the last data point. Okay? It's like you're doing this. You're going to every subinterval and you're saying, okay, the left edge, I use that height and I go over and down. Okay, next one, I use the left edge height over and down. Next one, the left edge over and down. And the last one, the left edge over and down. Okay, that's LRIM. Avery.
What would the units be for
What would the units be for that one if the rate's in feet per second? If you're using a trapezoidal sum and it's replacing an integral, feet, right? The approximate area would be feet because that's your displacement. That's approximating the displacement on that interval. Okay. All right. The fourth problem. This is going to be a weird fork. Okay. All right. Forks do have 4 prongs, don't they? It's the fancy hors d'oeuvre forks that have 3. We're not that fancy. All right. Where was I going? I got distracted. Average value of the function. Well, in a integral context, isn't the average value of the function 1 over b minus a times the integral from a to b of f of x dx? Yes? Average value of the function. Find the average water height of whatever they're talking about. Find the average rate of change of whatever. Average value. You have to do this process. Not just the integral. 1 over b minus a times the integral. So what if they ask you to find the average value of this function? Well, doesn't this part get replaced by the trapezoidal sum? So you would still need to multiply by 1/16. 1/16. 1 over 17 minus 1. Okay? That's enough prongs for now. Other questions? Keep them coming. I have one that I thought of that's related to this. It's like it's a relatively new question to the AP test in the context of how they ask it. It's with Riemann sums. Do you want to dive into that today? It's kind of weighty. Do you want to cover other review topics first? I didn't give you the multiple choice. I don't have the multiple choice for that year. 18, 17. I'm gonna have to find it. I was not planning on doing this, and then a neighbor asked that question, and I forgot. I forgot about that. To ln or not to ln? All of the answers are ln, so that was just for fun, but whatever. Avery, would you look at this? Using a trapezoidal sum with 3 subintervals, what is the approximate distance in miles the truck traveled? Now, distance it traveled, that's kind of a red flag to me to say total distance traveled. So the first thing my eyes get drawn to is, are there any negatives? Well, it's a truck. It's not going to have negative velocity, but they may do a negative velocity, not with a truck, but with something. I'm not saying to always use it, but you should at least have like your ears tuned into like listening for that. And your ears aren't going to be tuned into anything. Nobody's going to be talking to this exam, but your eyes should be tuned in. I'm dropping the analogy. All right. I may not find this. Ooh, there's a nice little, looks like a little U sub. No, it's not. It's not. In the context of, I'm getting distracted, but it's a good distraction this time. What kind of problem is this? 18. Fundamental theorem of calculus. Do you see how it's asking for the derivative of this thing? Tangent of 5x, secant of 5x. Now, here's what I want to make sure you guys are on the same page. Okay, this is not easy. We've covered it a lot. That doesn't mean anything. I want to see if you understand this. It's not easy. Does the -1 go away if you're asked for the derivative of this goop? It's been a while. It needed to be done. So you're saying tangent 5x, secant 5x minus 1 is your answer. I agree. You are going to hear things. You're going to hear Tyler's voice in your head. Just plug it in. That's what Jane would do.
Why do you think so more numbers
All right, we're going to have to go somewhere else. All right, I'm not seeing it. I'll try to find it for another day. All right, any more topics you want to talk about before we wrap up today? All right, remember, if you want more practice, it's on AP Classroom. There's a couple progress checks and released exams waiting anxiously for you. What's tomorrow? If you lit, Tom Sai, who's missing tomorrow? We'll miss you. We wish you the best of luck.
Mr. Westphal.
Yeah.
So the James probably before or after MVT?
Why?
I'm trying to find it in here somewhere. I have the most unorganized notes. Before?
It would be in 4, 6.
You don't like comp sci? I'm not even in your class. I just